This is going to be a quick introduction to the FuzzyLP package and how to solve a simple linear optimization problem using the FuzzyLP package in R. The FuzzyLP package is for fuzzy linear programming, so it's a package that you can use in R for solving linear optimization problems under uncertainty. For the purpose of giving an introduction to this package, I wanted to start with a video where I just go about a simple linear optimization problem. So the problem is stated here in scalar syntax. We have two optimization variables. It's a maximization problem, and you see the objective function here, 3x1 plus 4x2. And we have one constraint, which is a linear constraint, x1 plus x2 has to be smaller or equal to 1. And this is an optimization example in the continuous space. In order to solve this simple linear optimization problem using the FuzzyLP package, we have to convert this problem into a vector matrix syntax using the template as specified here. So we need to describe the problem using a cost vector or coefficient vector for the objective function, a vector with the optimization variables, and in order to explain or describe the linear constraints, we have to use a coefficient matrix and a constraint vector with the constraint values. In this case, the coefficient matrix for the constraints will be a 1-row, 2-column matrix. The constraint vector will be a single value vector containing the value 1. And the coefficient vector for the objective function will be a 2-element vector with the values 3 and 4. Okay, so down here in this quick example, which you can also find by clicking the link in the video description, I show to implement this in R. I simply have to define, after importing the FuzzyLP package, the cost vector, the coefficient matrix for the linear constraints. Then I need a vector describing with strings the direction of each constraint. In our case, we only have one constraint that is in the smaller than or equal direction. And then I also need the constraint value vector. In this case, it's a single value vector. So you can see here the coefficients for the objective function are 3 and 4. The coefficients for the constraint are 1 and 1, and the constraint value is 1 as well. So this is why I defined the matrices and vectors as I did. And now I can solve this simple linear problem using the CRISP-LP function, which is part of the FuzzyLP package. I have to provide to it the following parameters. I have to describe the objective. Here I simply hand over the coefficient vector for the objective function. I have to provide the coefficient matrix for the constraints. I have to provide a direction vector for the direction of the constraints, the constraint value vector as parameter b, and lastly I need to tell the CRISP-LP function that this is a maximization problem by setting the maximum parameter to true. Executing the function will perform linear optimization using basic simplex algorithm. In this case, I also catch the returned object or the returned list containing the solution and the optimal value to the problem. And below here, I output this list or this object that contains the solution and the optimal value to the problem. And you can see the optimal solution to this problem is x1 equals 0, x2 equals 1, and the optimal value that we can achieve is 4.